Okay, hi guys. So in this video, I'm going to finish the question that you saw in part 1 of elastic potential energy. So if you haven't watched my explanation on elastic potential energy, you should probably watch the video, then you proceed. Yeah. So the first question we solved it in part A of the video. So here we are going to focus mainly on part B and part C. So a quick recap to question A. So question A, we saw gravitational potential energy being converted into kinetic energy and later on into elastic potential energy. Then we said that the gravitational potential energy, this is the energy due to the height of an object. Then the kinetic energy is the energy an object possesses due to its motion. Then the elastic potential energy was the energy stored in the spring. So for every question you have to identify which energies are present and which energies can apply. So as you can see, initially when the car was at the top of the hill, it only contained the gravitational potential energy, which was due to its height. Then as it collided with the spring, at some point its momentum stopped. So which means when it stopped there, the spring was at maximum displacement, which means it also didn't have the kinetic energy. So you can go through that video. Then all this, and the final answer we solved it to be 0.51 meters to 3 significant figures. So always leave your answer to 3 significant figures if not specified. Then if the answer is also big, you can leave it in scientific notation. So now let's start part B, which says calculate the maximum acceleration of the car after contact with the spring, assuming no friction losses. Yeah. So part B. So it's also important to number as you are solving, so that the marker also knows that okay, this one knows what it's doing. So part B requires us to calculate the acceleration, which we don't know. So based on the data we have the spring constant, which is 1 million newtons per meter. Then we also have the maximum distance, which was 0.51 meters. So here, if the first part is long, so which means all the parts will be long. So you have to make sure you punch correctly on the calculator. Yeah. So next thing we need for us to calculate the acceleration is the mass. But you don't have the mass, you only have the weight, which is mg, which is equals to 13,000 newton. Yeah. So basically this is the that. So now how do we find the acceleration? So if you haven't watched my previous videos, you should go and watch, and don't forget to subscribe and like. So I'm saying, for those of you that didn't watch, I'm going to quickly drive the equation for acceleration. Yeah. So basically the acceleration, as you can see, we have two forces which act on the spring. So as Newton's third law of motion states that for every opposite reaction there is an equal opposite reaction. So yeah, well, let's see. So when the car, let's say this is the car and this is the spring. So when the car hits the spring, two forces are produced. We have one, the force which the car pushes the spring. Also we have the force which goes in the other direction, which is known as the restoring force, as we talked about. So the first force we have is the force which the car exerts on the spring. Then the second force is the restoring force. So we have two forces as the car hits the spring. So we say that this is equation 1, then this is equation 2. Yeah. So remember, in physics, you have to be good at good, one at substitution, two at changing the equations and substituting equations, making new ones, just like that. You should be practicing, because that's where physics rests. So then here you say that you can pick any equation here. So for me, I'll pick equation 1. So equation 1, which is force is equals to mass times acceleration. So I know that force can also be represented as negative kx. So here where there is F, I can replace with negative kx. So it will be negative kx should be equal to ma. Then I divide by mass. Even here I divide by mass. So there you get the equation for acceleration. Just like that. It was simple as drinking water. Yeah. So this is the formula for acceleration we are going to use to calculate for the maximum acceleration or the deceleration, since it's to be the final answer will be negative. But wait, we have also one problem. Here in the equation we only have what? Weight, not what? Mass. So again, you try to make now what? Mass the subject of the formula, since you have the weight and you know the equation for weight. So I'll drive it at the end. Yeah. So we know that weight is equals to mass times gravitational. But in our equation, we don't have weight. We only have mass. You have seen, ka? And in our equation, we don't have mass. We only have weight. So we need to make weight come into this formula. So again, here you have to use substitution. So first thing, you say that this one weight is equals to mass times gravitation will be equation 1. Then acceleration is equals to negative kx over m will be your equation 2. So here you can make what? So since we want weight, so we can make mass the subject of the formula in equation 1. So in equation 1, if you make mass the subject of the formula, it will be mass is equals to weight over gravitational field. Then we can substitute now where there is m here. We put what? Weight over gravitational field. So it will be acceleration is equals to negative kx divided by, so this over sign I've just changed it for easy calculation. So we have weight over gravity. So where there was m in this equation, I've put what? Weight over gravity. Then here it's just simple algebra. Negative kx multiplied by gravity over weight. So our final equation will be acceleration is equals to negative kxg over weight. So this is the equation now we are going to use to calculate for the acceleration in our question. So this is the equation now we are going to use to calculate for the acceleration. We have the spring constant, the distance, the gravitational field, and also the weight. Yeah. So physics mainly is based on the equation. You have to know how to play with the equation. Once you know how to play well with the equation, then you are home and dry. Yeah. So now let's solve since we have the equation. So before we solve, you can go through this simple derivation at your own time so that it sticks. Force is equals to mass times m. Then you have the Hooke's law. You combine Hooke's law and Newton to form the equation for acceleration. And you also combine the formula for acceleration with weight so that you find now the acceleration. Since the mass we don't have, we only have weight, so our equation should have weight. So you have to know how to change equations. Yeah. So here, step 1, then you make m the subject of the formula, then you replace m here, you get this a is equals to negative kx divided by, then you interchange according to laws of indices, then you multiply and you get the formula. So the formula we solved is, so the formula we got is acceleration is equals to negative k x times the gravitational over weight. So the spring constant we know is 1 million. Then the maximum distance we know is 0.51. Then the gravitational force we already know is 9.8. Then you divide by weight, which is 13,000 Newton. So if you punch on the calculator, you should get negative 380 meters per second squared. To our main significant figures 3. So this again shows that the spring really, the car was moving at a bigger speed. Yeah. So you see how physics questions are simple. It's just the part for making a formula to calculate, knowing which formula to use. Once you know how the concept applies, so the first thing should always write the equation you are going to use. Then you look for variables which are missing. Then you ask yourself, which equation can I get these variables? Just like that. So that's how you proceed in physics.